Good morning students. I hope you all are good. So today we will continue chapter number 4, that is measurement of matter. Today we are going to discuss molecular mass, concept of mole, valency and variable valency and chemical formula of compounds. Okay. So first of all, what is molecular mass? Okay, I will explain with the help of example. If I say find the molecular mass of a substance, say substance or is H2SO4, you have to find molecular mass. Find molecular mass of H2SO4. Then what you will do? So what you have to do, see, in these molecules or in this substance there is hydrogen, sulfur, S is sulfur, and O is oxygen. In these molecules, in H2SO4 or in sulfuric acid, there are total 3 different atoms. Which one? First one is hydrogen, second one is oxygen, sulfur, and third one is oxygen. So for molecular mass, you have to find individual atomic mass of all the atoms. Individual atomic mass I have written here in page number 49, that is given on page number 49 in your textbook. This one, page number 49. So I have written here atomic mass of hydrogen is 1, helium is 4, lithium is 7, beryllium is 9, boron 11, carbon 12, nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23, magnesium 24, aluminium 27, silicon 28, phosphorus 31, sulfur 32, chlorine 35.5, argon 36, potassium 39, calcium 40. No need to remember, okay. Whenever question will come, how find the molecular mass of the substance, atomic mass will be given, okay. So see, this is the simplest way I am explaining you. See, number of hydrogen atom is 2, so write here 2. Number of hydrogen atom is 2 into, see, atomic mass of hydrogen is how much? 1. Right, 2 into 1. Hydrogen finished, I have done. I have calculated atomic mass of hydrogen. Now we will calculate atomic mass of sulfur. So put here a plus sign. In these molecules, sulfur here is nothing. It means here is 1. So write 1 into atomic mass of sulfur is how much? Sulfur is 32. So 1 into 32. Sulfur is done. Now for oxygen, put your plus sign. Put a bracket. You can give bracket. Plus atomic, see, number of oxygen atom is 4, then write here bracket 4 into atomic mass of one oxygen atom is 16, so 4 into 16, this will be equal to 2 into 1, 2 plus 31 into 1, 32 into 1, that is 32, plus 16 for the 64, that will be equal to 0, 4 plus 2, 6 plus 2, 8, 6 plus 3, 9. 98 U. What is U? U is the unified atomic mass. Okay. So therefore the molecular mass of H2SO4 will be equal to 98. Understood? So if someone asks what is molecular mass, then how you will define molecular mass? So you can define molecular mass as the molecular mass of a substance. Molecular mass of a substance is the sum of atomic masses. Is the sum of atomic masses of all the atoms like hydrogen, sulfur, oxygen, all the atoms in a single molecule of that substance. But understood? What is molecular mass? The molecular mass of a substance is the sum of all the atomic masses in a single molecules of that substance. Okay? So in this way we can calculate atomic mass. I will take one more example. If I say find the molecular mass of carbon dioxide, CO2. Same one, find molecular mass. Okay? So again what you will do, here carbon atom is 1, so write here 1 into the atomic mass of carbon is how much? 12. So we will write 1 into 12 plus sign plus. Now we are calculating atomic mass of oxygen. Here put a bracket. Number of oxygen atom is 2, so write here 2 into number of oxygen, atomic mass of oxygen is how much? 16. So that is 16. 12 plus 32. That will be equal to 44 U. Unified atomic mass. Okay. One more thing. I will explain mole concept in this example. From this example. See. In place of U, or simply if you express molecular mass of a substance or a compound in gram. See, here atomic mass of H2SO4 is equal to how much? 98. So if you write in place of 98 gram, if you represent molecular mass in gram, then this will be equal to 1 mole. I mean to say, we can write here 98 gram H2SO4 is equal to 1 mole. Understood? I mean to say, if you represent atomic mass of a substance in gram, then that will be equal to how much? 1 mole. That will be equal to 1 mole. And 1 mole is equal to 6.022 into 10 raised to 23 maybe atoms, molecules, ions, etc. Always remember, 1 mole is equal to how much? 6.022 into 10 raised to 23 atoms, molecules or ions. Here is molecules, so we can say 1 mole is equal to 6.022 into 10 raised to 3 molecules of H2O. From this example, we can say that 1 mole is equal to 1 mole of H2SO4 is equal to 1 mole of H2SO4 is equal to 6.022 into 10 raised to 23 molecules of H2SO4. This is an important concept. 1 mole is equal to 1 mole of H2SO4 is equal to 6.022 into 10 raised to 23 molecules of H2O. Understood? Similarly, if you represent this 44, if you represent molecular mass in gram, similarly we can write here 44 gram. See, here is unit, here is gram. 44 gram CO2 is equal to 1 mole. Always that if you express molecular mass in gram, then that will be always equal to 1 mole. 1 mole of CO2. 1 mole of CO2. This is very, very important concept. If you represent molecular mass in gram, then that will be equal to how much? 1 mole. It means 44 gram CO2 is equal to 1 mole of CO2. And we know this will be equal to, and we know that 1 mole is equal to how much? 1 mole is equal to, all three are equal. 44 gram of CO2 is equal to 1 mole of CO2 is equal to 6.022 into 10 raised to 23 molecules of CO2. These all three are equal. This is very, very important. Understood? So why we use mole concept? If I say 50 gram sugar is equal to how many molecules are there in 50 gram sugar? So it is very difficult to count, but with the help of mole concept we can find how many molecules of sugar is present in 50 gram or 100 gram or whatever. So mole concept is used to find number of molecules, atoms or ions in any substance. Okay? So that's why we are studying mole concept. One example is given on page number 52. I will write a questions that will be important. See, how many molecules are there in 66 gram of CO2? You have to find number of molecules in 66 gram of CO2. So first of all, you have to find molecular mass of CO2, and that if you find molecular mass and you have to convert that molecular mass into gram. So what you have to do, first of all, you will find molecular mass of carbon dioxide. So we will write here molecular mass. Solution, we can write here solution. That is given in your textbook page number 52. Method may be different, but answer will be same. Solution. Molecular mass of carbon dioxide is equal to, see, again, number of carbon atom is 1. So 1 into atomic mass of carbon is 12. 1 into 12. In between, now we are calculating atomic mass of oxygen. So we will put here plus. Number of oxygen atom is 2. Put the bracket 2 into. Now atomic mass of oxygen 16. So this will be equal to 12 plus 32. That will be equal to 44. Now right here gram. what you have to do, you have to find molecular mass in the gram, and this will be equal to 1 mole. So 44 gram of CO2 is equal to 1 mole. So we can write here, since 44 gram CO2 is equal to 1 mole, and 1 mole is equal to how many molecules or atoms? So here we are counting number of molecules. So 44 gram of CO2 is equal to 1 mole, and we know that 1 mole is equal to how much molecules? 6.022 into 10 raised to 23 molecules. So here molecules of 6.022 into 10 raised to 23 molecules of carbon, because we are calculating number of molecules for carbon. So we will write here 6.022 into 10 raised to 23 molecules of carbon. So 44 gram of CO2 is equal to, now take these two, this and this. So we can write here 44 gram CO2 is equal to 6.022 into 10 raised to 23 molecules of carbon dioxide. So 1 gram, therefore we can have since 44 gram of CO2 is equal to 6.022 into 10 raised to 23 molecules of CO2. Therefore 1 gram of CO2 is equal to, this will be equal to 6.022 into 10 raised to 23 divided by 44 molecules of CO2. Therefore, unitary method we are using here. 66 gram of CO2. Therefore, 66 gram CO2 is equal to 6.022 into 10 raised to 23 divided by 44 into 66 molecules of CO2. 22 to the 44, 23, 22 3 the 66, 3 upon 2, that will be equal to, oh, there is no space. Okay, there is no space, so I will erase the atomic mass. So 3 upon 2, that will be equal to 1.5. 3.2, that is equal to 1.5 into 6.022 into 10 raised to 23 molecules of CO2. So you have to multiply these two only. So you will get 9.033 into, you have to multiply only these two, into 10 raised to 23 molecules of CO2. So therefore 66 gram of CO2 is equal to how many molecules? 9.022 into 10 raised to 23 molecules of carbon dioxide. So therefore we can write here 66 gram CO2 is equal to 9.033 into 10 raised to 23 molecules of, this is the answer. One more method I want to tell you how you will calculate number of molecules. So next method I will tell you. Next method is method 2. Answer will be same. Method 2. First of all, find number of mole in 66 gram of CO2. So there is one formula. Method 2. One formula. If you find number of mole is equal to number of mole which represent small n. Number of mole is equal to mass of the molecular mass or we can say mass of the substance in gram upon molecular mass of substance in gram. There is one formula. So first of all, what you will do, you will find how many moles are there in 66 gram. So how you will calculate number. So in this case, number of mole n is equal to mass of the substance in gram. So mass of the substance is equal to 66 gram is given. So that's 66 divided by molecular mass of the substance in gram. Here molecular mass of substance means what? Here molecular mass of carbon dioxide. If you take since question says how many molecules are there in 66 gram of CO2, so we will consider molecular mass of the substance in gram is here we will take molecular mass of carbon dioxide. So here we will take molecular mass of carbon dioxide, and just few minutes ago we had calculated molecular mass of carbon dioxide is how much? 44. So 22 to the 44, 22 3 the 66. That will be equal to 3 upon 2, that is equal to 1 upon 5 mole. Right? So 66 gram of CO2 is equal to how many moles? 1.5 mole. And we know that since 1.5 mole, and we know that 1 mole is equal to how many molecules? Since 1 mole is equal to 6.022 into 10 raised to 23 molecules, right? So therefore 1.5 into 1 mole is equal to 6.022 into 10 to 23 molecules. Therefore 1.5 mole is equal to how much? So 1.5 into 6.022 into 10 raised to 23 molecules. So if you multiply these two, you will get 9.033 into 10 raised to 23 molecules of CO2 in 66 gram of CO2. So this is the another method. So this is important. On the same concept, you can calculate question number 7. Question number 7 and 8. Question number 7 and 8, page number 57. So on the same concept you can do. Okay. So now next topic I will take How? Listen. This is one thing I will explain. Avogadro number. It is represented by capital N and small a. The number 6.6.022 into 10 raised to 23. This number is called Avogadro number, and it is represented by Na. Na means Avogadro number. Okay. Now, concept of valency. Before concept of valency, I will explain compounds. Okay. So compounds, there are two types of compounds. Covalent compound and ionic compound. Examples: covalent compound like H2, CO2, like HCl, O2, etc. These all are covalent compound. Ionic compound NaCl, MgCl2. So what is compounds? I have already explained. I repeat again. When two or more than two atoms combines in a fixed proportion, then a compound is formed. Okay. What do you mean by covalent compound? So in covalent compounds, there is a bond formation between two atoms. There is a bond formation. There will be a bond formation on the basis of sharing of electrons. But in case of ionic compounds, there is complete transfer of electrons from one atoms to another atoms. So difference is, in covalent compounds, electrons are shared in a chemical bonds, and in ionic compounds, one atoms completely release or give the electrons or the most electrons to the other atoms. Okay. So in this case, H2, it means there are two hydrogen atoms. So in H and H, there is two hydrogen, there is single bond. So actually in this single bond, one electron of this hydrogen atom and the another electrons of this hydrogen atom. So there is a sharing of electrons. CO2. In CO2, oxygen, here is one carbon atom and two oxygen atom. See, therefore the valency of oxygen will be, since there is two chemical bonds for oxygen atom, two chemical bonds for oxygen atom, therefore the valency of the hydrogen oxygen atoms will be 2. But here there are 4 bonds, 1, 2, 3, 4. So valency of the carbon atom will be 4. Similarly, here if you consider this hydrogen atom, so for this hydrogen atoms there is only one single bond. So the valency of the hydrogen atom will be 1. And if you consider this hydrogen atoms, there is only one bond, one chemical bond. So valency of the carbon atom will be, hydrogen atom will be 1. Similarly, HCl. HCl. So again there is one electrons of this, there is one electrons for this hydrogen and one electrons is for this chlorine. So the valency of the hydrogen atom will be 1 and the valency of the carbon atom will be, chlorine atom will be 1 again. Okay, but in case of ionic compound, sodium atom gives its outermost electrons completely to chlorine atoms. Similarly, magnesium atoms gives completely electrons to the chlorine. So I will explain in detail. So what is valency? Next topic is valency. So valency, we will define valency for covalent compounds. Simply valency is the combining capacity of an element. This is a general definition. But if you study in detail, so we can define valency for two compounds, for covalent compounds and for ionic compounds. Understood? So first of all, what is valency for covalent compounds? So I will read on page number 53 that is given. Till standard 8th, you have studied that valency is the combining capacity of an element. But in standard 9, some more explanation needed. So you can define valency for covalent compound is like the capacity of an element to combine is called its valency. The valency of an element is indicated by a specific number. It is the number of chemical bonds. It is the number of chemical bonds formed by one atoms of that element with other atoms. See, number of chemical bonds for covalent. What is valency for covalent compounds? So you will define. It is the number of chemical bond. It is the number of chemical bonds formed by one atom of element with other atoms. That is called valency. Valency is the number. For example, in this case, hydrogen, there is one chemical bond for this hydrogen. If you consider this, so there is one chemical bond for this hydrogen, so valency will be 1. Again here valency for this hydrogen is 1. Similarly, the valency, there is one chemical bond, so the valency of chlorine will be 1. But here in this case, if you consider carbon, so there are 4 chemicals bond, 1, 2 to this side and to this side. Therefore, the valency of carbon will be 4. But if you consider only this oxygen, so this oxygen atom, there are only 2 chemicals bond, 1, 2. So valency of the oxygen will be only 2. Okay. Now valency, what is the valency for ionic compound? So before definition, I will give you the example, one example. On the basis of that example, you can understood what is the valency for ionic compound. Okay. So I will take next topic, that is formation of sodium chloride. How a sodium chloride is what? That is salt we use in our daily life. Formation of sodium chloride. Formation of sodium chloride, that is NaCl. So in case of sodium chloride, this is ionic compound. So formation of sodium chloride, there are 2 atoms. One is sodium and second is chlorine. So in case of sodium, atomic number of sodium is, say this is sodium atom. Understood? This is the nucleus. This is the nucleus in which protons and neutrons are there. This is first orbit. In first orbit there are total 2 electrons. Okay, right. First of all, electronic configuration of sodium. Sodium atomic number 11. I will tell how to write sodium electronic configuration. Atomic number 11. So in first orbit there is 2 electrons. In second orbit there is total maximum 8 electrons. 8 plus 2 that is 10, 1. Now 8 plus 2, 10 plus 1, 11. Similarly write electronic configuration for chlorine atoms. So for chlorine, atomic number is 17. So in first orbit there are 2 electrons. Second orbit 8 electrons. 8 plus 2, 10. And in last orbit there are total 7 electrons. Next topic is, I will explain how to find valency of an element. Okay, so don't worry, sir, I am not getting. In case of sodium, in first orbit there is 2 electron, 1, 2. Second orbit, this represent orbit. First orbit, the second orbit, third orbit. First orbit represented by capital K, L, M, N, so on. Second orbit, how many electrons are there in sodium? In second orbit there are total 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And in the last orbit there is only 1 electron. Last orbit is called valence shell, and the electrons present in the valence shell is called valence electron. So there are total 1 electrons in case of, there is only 1 valence electron in case of sodium atom, plus chlorine atom, plus chlorine. This is the sodium atom. This is sodium atom. There is no any positive or negative charge, because the number of protons and number of neutrons are equal. So net resultant charge is 0 on any isolated electrically neutral atom. Chlorine, again nucleus. In the first orbit there is in the nucleus there is proton and neutrons. In the first orbit, how many electrons are there? 2 electrons. 1, 2. In second orbit, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Last orbit, in the third orbit, 7 electrons. 1, 2, 3, 4, 5, 6, 7. I have to erase this because I have no space. So actually this is chlorine atom. Okay. So in the formation of sodium chloride, sodium atom gives 1 electrons to chlorine atoms. Now this is, I will write here. Okay, this is chlorine. This is chlorine atom. I will draw here because the space is not sufficient to draw here. So I will sodium. So in sodium, in case of sodium, again there is protons plus neutrons. There is first orbit, again there is 2 electrons. Second orbit there is 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And in the third orbit there is no n electrons, since this electron is given to chlorine atoms. So on this atom there is a positive charge. The reason why there is positive charge, the reason is, since we know that number of electrons and protons both are equal for an isolated electrical neutral atoms. So here is 11 protons and 11 electrons. But now protons, since protons are in the nucleus, there are 11 protons and 11 electrons. But now what happened? Now this electron is given to chlorine atoms. So 11 protons, and there is 10 electrons and 10 electrons. So electron is negatively charged, protons is positively charged. So 11 electrons, 11 protons neutral, cancel out. There will one proton is remaining. So on protons there is positive charge. So there is, that's why I have written here one positive charge, because one proton is extra. Okay. In case of, now this is Na plus. Na plus represent there is one less electrons. I mean to say Na plus, it means they have given one electrons to different atom. Here different atom is chlorine, maybe bromine, but in case of different atom here is chlorine. Na plus means they have lost their one outermost electron. Of course they have lost their one electrons, that's why there are one positive charge. If I write Ca2 plus, it means they have lost, calcium atom has lost two valence electrons. Okay. Now chlorine. In case of chlorine, again there is protons and neutrons. This is nucleus, protons plus neutrons. First orbit 2 electrons, 1, 2. Second orbit 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. And in third orbit, initially there was total 7 electrons, but now there is total 8 electrons. 1, 2, 3, 4, 5, 6, 7. 7 electrons. But since this atom has given 1 electron to the chlorine atoms, there is 1 electrons. Since initially there was total 17 electrons and 17 protons. 17 electrons negatively charged, 17 protons positively charged. So negative charge, positive cancel out. Since 1 electrons added extra, so there will be a negative charge. Understood? There is a negative. This is Cl minus. Cl minus means they have taken 1 electron. Okay. So in this way, this is the entire formation of sodium chloride. Now the definition of valency for ionic compound is, definition is the number of electrons that an atom of an element gives away or takes up while forming an ionic bond is called the valency of that element. Here, since sodium has given 1 electrons to the other atom, so the valency of the sodium will be 1. Similarly, here chlorine atom have taken 1 electrons from the sodium atom. Since 1 electron is taken by the sodium atom, so the valency of the chlorine will be 1. Okay. So I hope you understood formation of sodium chloride and valency as well. Now there is variable valency. Next concept is variable valency. Okay, before variable valency, I will tell you how to write electronic configuration. Page number 54. So one table is given on page number 54. So you have to complete the table, okay? So students, always remember, in first orbit, maximum 2 electrons can stay. Second orbit, 8 electrons. In first orbit, maximum 2 electrons. The capacity of the first orbit is maximum 2 electrons. The capacity of the second orbit is maximum 8 electrons. In third orbit, there is a capacity of 18 electrons. 18 electrons can stay in the third orbit. Okay. Actually, there is one formula to find capacity of how many electrons can stay in a particular orbit. So there is one formula, 2n square. This is the formula where n is the orbit number. N is the orbit number. If you put n is equal to 1, then it means you are talking about first orbit, that is K shell. If you put n is equal to 2, it means you are talking about L shell, orbit number second. So if you put n is equal to 3, it means there you are talking about orbit number 3. So but remember, students, remember, in your syllabus, you have to take only in first orbit 2 electrons, in second orbit maximum 8 electrons can stay, in third orbit 8 electrons. Capacity of the third orbit is 18, but you have in your syllabus till 9 or even 10, you have to remember that in first orbit you will put only first orbit 2 electrons, second orbit maximum 8 electron, in third orbit again 8 electron. Okay, and in the fourth orbit you can 8 electrons, but that in fourth orbit, the capacity of the fourth orbit is, if you put here 4, so 4 square into 2, 4 is 16, 32 electrons. But in your syllabus, this is sufficient. Always remember 2, 8, 8, 8. This is more than sufficient. But again I am telling you, the capacity of the third orbit is 18. Capacity of the fourth orbit is 32. But in your syllabus, for writing electronic configuration, you remember just in first orbit you have to put only 2 electrons maximum. Second orbit again 8 electrons. Third orbit again 8 electrons. Remove this. This is sufficient for your syllabus, till your syllabus. So atomic number is given. Electronic configuration. Here is atomic number 1. But we know that in first orbit maximum how many electrons can stay? Maximum 2. But here is only 1 electrons. So easily we can put the 1 electron. And valence electron. Valence electrons is what? Valence electrons means electrons present in the outermost orbit is known as valence electron. So since there is only one shell, there is only one shell. In case of hydrogen, the valence electron will be 1, its valency will be 1. This is exception, you remember this. Atomic number 2, electronic configuration. In first orbit, the capacity of the first orbit is 2 electron. So easily we can put 2 electrons. Valency, valence electron 2, valence electron 2. Valence electrons means electrons present in the outermost orbit. So in case of helium, there is only 2 electrons. On the basis of this, we are writing here valency. Remember students, this is exception. In case of helium, 2 minus 2 is equal to 0 valency. You remember this is exception. In case of helium, there is exception. Okay, in chemistry there are so many exceptions are there. Lithium, atomic number 3. So we can't write electronic configuration 3. You have to write electronic configuration like in first orbit maximum 2 electrons. So write here 2 electrons. Now 1 electrons will be going the next orbit. This is first orbit, this is second orbit, this is third orbit. First orbit maximum 2 electrons can stay. Second orbit, there is capacity of 8 electrons, but you have only 1 electrons because 2 already put it in orbit number 1. So here is only 1. So valence electron, how many valence electron? Valence electrons means outermost number of valence electrons present in the valence electron. Valence shell 1. Valency again 1. Valency we are writing on watching this. Beryllium, atomic number 4. So in first orbit we can place 2 electrons. Total 4 electrons. This represents atomic number means number of protons and number of electrons, and we know that number of protons is equal to number of electrons. So in case of beryllium, total there are 4 electrons. So in out of 4 electrons, you have placed 2 electrons in the first orbit. So 2 will be remaining. So there the capacity of the second electrons is of 8 electrons, but here is still only 2 electrons because in first orbit 2 electrons, in second orbit again 2 electrons. 2 plus 2 4. valence electron. This represent valence electron 2. Valency will be 2, then 2. Boron, atomic number 5. It means number of electrons and protons is equal to how many? 5. So in first orbit, we can put 2 electrons. Still 3 electrons is remaining. So in second orbit, we can put here 3 electrons. So valence electron again 3. Valency will be 3. Carbon 6 electron and 6 proton. The first orbit 2 electrons, 4 still is remaining. In first orbit 2 electrons, second orbit 4 electrons. Valence electron 4, right here 4. Valency will be equal to this one 4, right here 4. Nitrogen, atomic number 7. In first orbit 2 electrons, second orbit, in first orbit 2 electrons, second orbit 5 electrons. Valence electron is 5. Valence electron is 5. Here valency, remember, if valence electron greater than 4, valence electron greater than 4, in that case, remember, valency will be equal to 8 minus valence electron. Remember, here valence electron is 5. 5 is greater than 4. So its valency will be 8 minus valence electron. Valence electron is 5. 8 minus 1, that is equal to 3. Oxygen, atomic number 8, means 8 electrons and 8 protons. It means in first orbit 2 electrons, second orbit 6 electron. Valence electron again how many? 6. Since valence electron is more than 4, 6 is more than 4, valency will be 8 minus valence electron. Valence electron is 6. Valency will be 8 minus, that is equal to 2. Fluorine, first orbit 2 electrons, in second orbit 7 electron. Valence electron is 7, and for valency, since valence electron is more than 4, valency will be 8 minus valence electron. Valence electron is 7, that is 1. Neon, 2, first orbit 2 electrons, second orbit 8 electron. Valence electron is 8. So right here 8. Since 8 is greater than 4, valency will be 8 minus 8 is 8 minus number of valence electron. 8 minus 8 is the number of valence electron, that is equal to valency will be 0. Sodium, 2, first orbit, don't write 9 because the capacity of the second orbit is 8. So in second orbit we can't place here 9 electron. So you have to put in second orbit 8 electron. 8 plus 2, 1 is still remaining. So 1 electron will be go in the next orbit. So 2, 8, 1. So valence electron again, valence electron is 1. 1 is, so valency, see, valence electron is 1, valency will be 1 because this is not greater than 4. Magnesium, 2, don't write here 10, this is wrong because the capacity of the second orbit is of 8 electron. So write here 2, 8, 8 plus 2, 10, 2 is remaining. So then 2 electrons will be go in the next orbit. Valence electron is 2, right here 2, valency will be 2. Okay? So next topic is variable valency. Some elements have variable valency. Understood? So I have taken 3 examples: elements, symbol, valency, ion, nomenclature. So element, I have taken copper. The symbol of copper is Cu. Copper have two valency, one and 2. Since this element copper have 2 valency, then copper will come in the category of variable valency. Okay? valency 1. So ion will form Cu plus. Cu plus means what? Copper have given 1 electrons to the different atoms. Similarly, if you write Cu2 plus, it means copper have given 2 outermost electrons or 2 valence electrons to different atom. How many electrons they have given? 2 electrons. So if Cu plus, ions means what? If any atom have charge, then that is called ion. If there is positive charge, that is called cation. If on any elements there is positive charge, that is called anion, cation. And if there is any negative charge on any element, that is called anion. Okay. So its nomenclature is, if there is one plus charge, it means its nomenclature will be, it is called cuprous. It is called cuprous. Cu2 plus, this ion is called cupric. Okay. Similarly, mercury symbol, the symbol of mercury is Hg, capital H small g. They have also 2 valency, 1 and 2. So Hg1 plus, only plus means 1 plus. Hg2 plus, same, this mercury have given 2 electrons to different atom. 1 plus, it means 1 electron have given to different atom. Hg plus is called mercurous. Ag2 plus is called mercuric. Okay. Similarly, iron, symbol Fe, variable valency, they have 2. Iron have 2 valency and 3 valency. 2 valency, that is called Fe2 plus and Fe3 plus. This is all are cation. If I write Cl minus, this is the example of anion. It means they have taken 1 electron. Okay. 2 plus is called ferrous. And this 3 valent is called ferric. Okay. So under different condition, the atoms of some elements have given away or take up different number of electrons. In such case, those elements exhibit more than 1 valency. More than 1 valency means maybe 1, maybe 2, 1, 2, 2 or 3. This property of the element is called variable valency. Okay. Now radicals. Now next topic is radicals. Next topic is radicals. Radicals, what is radicals? Radicals means group of atoms having some charge. It is the group of atoms having some charge. Okay. So radicals are of 2 types. First one is basic radicals. Basic radical. Or cationic radicals, or cationic radicals. and second is acidic radicals or anionic radicals. Okay, basic radicals or cationic radicals, always plus charge, maybe one plus charge, 2 plus charge, 3 plus charge, that we will see later on. Okay, acidic radical or anionic radicals, that is negative charge, it is fixed. If we are talking about basic radicals, it means there must be some charge, and then that some charge will be positive in nature. Acidic radical or anionic radicals, that is there must be negative charge on acidic radical or anionic radical. Okay, for examples, Ag plus, actually this is ion, single atom is there, that is ion. If more than one atom will be there, then that is called radicals. Cu 2 plus, Fe 3 plus, Al 3 plus, etc. Anionic radicals, that is S of capital A, S capital O 4, 2 minus CO3, 2 minus phosphate PO4, 3 minus, etc. Okay, so one more thing I want to tell you, Ag plus, it means this plus represent valency. Okay, so Ag plus means silver has only valency 1. 2 plus, it means copper have 2 valency 2. So with the help of acid radical or basic radicals, we can find valency of that radicals. Okay, or of that atom. Fe3 plus, 3 plus represent valency. This is very, very important. On the basis of given radicals, you can find valency of the elements or atoms or radicals. Valency of iron is 3. Similarly, Al3 plus, it means valency of aluminium will be 3. Similarly, SO4 means sulfate, 2 minus, it means valency of sulfate is 2. Similarly, CO3 2 minus, it means valency of CO3 means carbonate, the valency of carbonate is 2. PO4 3 minus, minus represent they have taken 3 electrons. They have taken 3 electrons. 2 minus means they have taken 2 electrons. PO4 phosphate. PO4 means phosphate. Page number 56. One table is given. Students, see this one. SO4 2 minus. SO4 2 minus. SO4 means sulfate. Sulfate have valency 2. Similarly, phosphate PO4 phosphate have valency 3. Valency 3 minus. Valency of phosphate is 3. This is very, very important to write the name of the formulae. Next topic is how to write the name of the formulae. So first of all, you should know how to find the valency from given radical. you must know how you will calculate or how you will find valency from given radicals. Okay, if I write here bicarbonate HCO3 minus, so can you tell me this is basic radical or acidic radical? So you can say, sir, here is minus sign, negative sign. It means this will come in the category of acidic radical. Okay, this will come in the category of acidic radical. So can you tell me the valency of this bicarbonate? H2O3 means bicarbonate. Its valency will be 1. Only minus means valency will be 1. Okay. If I write Na plus, if I write H plus, if I write OH minus, if I write Cl minus, can you tell me which one is cation, which one is anion? Cation means positive charge on the atom. So these two are cation. Cation. These two are anion, since there is negative charge. Okay, or we can say this is the positive radicals. Actually, if there is more than one atom now, then you can consider as the radicals. Otherwise, you can say this is simply ion, cation. This is anion. This can consider you the radical, since oxygen and hydrogen is there. So this positive charge on any atom, that is called cation or positive radicals or basic radical. Minus charge, anion. If group of atoms are there, you should prefer radicals. So here is negative radicals or anion. Now next and last topic is how to write the chemical formulae of a compound. Okay, before chemical formulae of a compound, you must know what is monoatomic radicals and composite radical. Mono means single. Mono means single. If I write Na plus, monoatomic, this is the example of monoatomic. Don't say there are two atoms. Sodium A is the, Na is the symbol for sodium. If I write here K plus, this will come in the category of monoatomic radicals. If only there is one atom, if there is only one atom, that will become in the category of monoatomic radical. If I say H plus, monoatomic radicals. Composite radicals means what? If there are more than two atoms and there is charge. If more than two atoms are there, then that is composite radicals. For example, CO3 2 minus. Here carbon is there and oxygen is there. There are two different atoms. So this will come in the category of composite radicals. PO4, or we can say HCO3 minus. So this will come in the category of composite radicals. The reason is here is more than one atoms. Here is hydrogen, carbon, oxygen. So this will come in the category of composite radicals. Okay. So how to write the name of the compound? Okay. Chemical formula of a compound. Okay. If I say write sodium carbonate. If I say in English we can write easily. Sodium. First example, sodium. It is easy to write in English language, sodium carbonate. But in chemistry language, how you will write? So what you have to do? The symbol of sodium is Na, and the symbol of carbonate is on page number 56. 56. Carbonate CO3 2 minus. CO3, you can see here CO3 2 minus. No need to write CO3 2 minus. No need to write 2 minus, because 2 minus represent they have taken or they have accepted 2 electrons. So write only CO3. Actually on page number 56 that is given carbonate CO3 2 minus. These 2 represent valency. So don't write these 2 minus. So write only CO3 3. Okay. And the sodium, valency of sodium is 1. Right here 1. And since in the textbook CO3 2 minus is given, so these 2 minus, so you will write only 2. You will write only 2. It means this is the symbol. This is the symbol. This is the valency. Sodium valency 1, carbon valency 2. Don't write here 2 minus or PO4 minus. 2 minus, you will, in place of 2 minus, you will write only 2. Minus represent they have taken 2 electrons. Now cross multiplication. So we can write here Na2 minus, Na2. If there are more than 1 atoms, then put a bracket. If there are more than 1 atoms, if there are more than 1 different atoms, then put a bracket. Since carbon and oxygen is there, 2 different atoms, so you will put a bracket. No space. No need to put a space. CO3, bracket close. Now you write 1. This 1 you have to write. So 1, no need to write 1. We don't write 1. So the chemical formula will be, this is Na2CO3. No need to write 1. 1 drop from here. It means in English language you will write sodium chloride like this, but in chemistry language you will write sodium chloride means Na2CO3. Okay. Okay, right. Next, so calcium carbonate. Calcium phosphate. So again, valence symbol, calcium symbol. Here will be radio. Here will be valency. See on page number 56. Symbol of calcium, that is Ca2 plus is given. 2 plus 2, Ca2 plus. So this 2 plus represent valency. 2 plus, it means in place of valency you will write only 2, not plus, only 2 you will write. Symbol, that is Ca. Phosphate, again in the text page number 56, phosphate, that is PO4, 3 minus is given. So write only PO4, don't write 3 minus. 3 minus represent its valency. So 3 you will write here. Not write minus. Only 3. Okay. So again cross multiplication. So it will be Ca. Don't think sir here is 2 atoms. No. Ca is the symbol of calcium. So don't put a bracket here. Okay. Ca3. Here more than 2 atoms are there, phosphorus and oxygen. So we will put a bracket. PO4, bracket close, and write 2. So this in English you will write calcium phosphate like this, but in chemistry language if I write Ca3 bracket PO4 4 brackets close 2, it means this represents calcium carbonate. So this is the molecular formulae of calcium phosphate. Okay, right here. Next, if I take calcium carbonate, calcium carbonate. In English you can write easily calcium carbonate. It is easy. But in chemistry, how will you write carbonate? So the symbol of carbonate is in the textbook that is given CO3 2 minus. So these 2 minus in the place of valency you will write 2. And symbol is CO3, capital O, beta. This is capital O. Okay. This is important. The reason is, since 2 come in the table of 2, you can cut here. 2 1 the 2, 2 1 the 2. Understood? Now here is 1. Don't think it is 2 because you have done cancel out. So it will be CA1. More than 1 atoms are there. We will put a bracket. CO3 bracket close, then 1. No need to write 1. It will be CO. Remove the bracket from here. Okay. If you will remove the bracket from here, this will be like CaCO3. It means in chemistry, if I write CaCO3, it means calcium carbonate. Okay. One more example I will take. Magnesium chloride. On page 56, here will be symbol Mg. In your textbook, the same Mg2 plus is written. Mg2 represent valency. So valency will write here. Chloride in your textbook given Cl minus. So minus means 1 minus, only 1 minus. So write here 1. And symbol will be Cl. Okay. So it will be Mg1. There is only 1 atom, so no need to write bracket. Cl2. No need to write 1. So this will be equal to MgCl2. So in chemistry language, if you want to write magnesium chloride, then you can write MgCl2. That's all. So this was chapter number 4, that is measurement of matter. So question answer. Exercise on page 56, exercise is given. So for question answer of chapter number 4, I will share the link in the group. So you can write the answers from all the answers of exercise from that link. Okay. So thank you so much. Have a nice day. Thank you.